When you flip on a light switch, your eyes adjust, the space illuminates, and your brain tells you you are perceiving complete reality. The physical universe, however, is actually vibrating with invisible electromagnetic waves. In the 19th century, physicist James Clerk Maxwell proved that oscillating electric and magnetic fields propagate through space, forming a massive continuum of energy. Right now, you are sitting in a dense storm of these waves. They are washing off you from distant galaxies, radiating from the Earth's surface, and transmitting from the phone in your pocket. Yet you are completely oblivious to almost all of them. Human vision is a highly restrictive biological filter, blocking out nearly everything the universe has to show us. This timeline charts the full electromagnetic spectrum. It classifies these waves by their frequency, stretching all the way from massive radio waves on the low-frequency end to ultra-short gamma rays on the high-frequency end. A single radio wave can stretch out for hundreds of kilometers, while a gamma ray compresses its energy into a space smaller than an atom. If we scan across this vast expanse to find the specific waves our eyes can actually detect, we have to zoom way in, past the microwaves, past the infrared, to isolate this single razor-thin sliver near the middle. Every star you've seen, every painting ever created, and every face you recognize exists strictly inside this microscopic slice of physics. We map the borders of this sliver starting at the lower energy threshold, where infrared ends and red vision begins. At this boundary, the wave oscillates at 4 × 10 to the 14th power hertz, a physical wavelength of about 700 nanometers. Moving across the familiar colors of the rainbow, the frequency increases until we hit the upper energy threshold, right before ultraviolet begins. Here, the wave oscillates at 7 × 10 to the 14th power hertz, with a compressed wavelength of roughly 400 nanometers. Out in the vacuum of space, there is no physical wall separating these specific waves from the rest of the spectrum. A wave at 3.9 × 10 to the 14th hertz behaves mechanically the same as one at 4. The physics of the electromagnetic field remains perfectly continuous. The numbers 4 and 7 × 10 to the 14th hertz simply represent the strict mechanical limits of human biology. Your eye functions as a highly specialized organic antenna, physically calibrated to receive only this specific set of frequencies. When electromagnetic waves within our target range bounce off everyday objects, they funnel through your pupil and strike the retina at the back of your eye. This visualization shows how your brain processes that data. It translates the raw physical frequency of the wave into the psychological sensation of color. A lower frequency wave registers in your mind as red, while a faster, compressed wave triggers the sensation of violet. Color and brightness are entirely internal physiological translations constructed by your nervous system. Because vision relies on these specific organic antennas, what counts as visible is completely relative to the life form doing the looking. Many snakes are equipped to detect frequencies well below our 4 × 10 to the 14th hertz limit. They absorb the infrared waves emitted by warm bodies, allowing them to track prey through dense brush at night. Many insects have antennas tuned to frequencies above our 7 × 10 to the 14th hertz limit. When a bee looks at a flower petal, it navigates using intricate ultraviolet patterns that remain completely imperceptible to us. A forest that looks pitch black to a human hiker is simultaneously glaringly bright to creatures tuned in to those surrounding frequencies. In physics, the visible rays category is just one standard region of the electromagnetic spectrum. It holds no special physical properties. It is categorized purely by our anatomy. The data is definitive. Human visible light exists strictly between 4 × 10 to the 14th hertz and 7 × 10 to the 14th hertz. The light we see doesn't grant us an omniscient view of the universe. We are passengers, experiencing a vast and invisible cosmos through a very specific, beautiful, but extremely narrow window.